Alexa, turn on the weather ball.
Okay.
Okay, so this will be more like a code walkthrough, but what we're going to build is a weather ball. And in my town where I grew up in Grand Rapids, Michigan, there was this thing called a weather ball. And essentially, what it was this gigantic sphere that lived on top of a building. And it would change colors and do different things to tell you what the weather was going to be the next day. And it was around in like the 60s and 70s, but I think in the 80s it fell apart or blew off the top of this building. And then right around 2000 or so, uh, the TV station found it in a dump down in Kalamazoo, and they brought it back and put it up. And so if you drive around in Grand Rapids, you can see this weather ball, and it gives you some indications of what the weather is. So it does two things: it either blinks or not blink, and it gives you three different colors. So if it's red, it's going to be warmer tomorrow. If it's blue, it's going to be colder tomorrow. If it's green, it will be relatively the same temperature as today. And then if it's blinking, it's going to either be raining or snowing based on the temperature. Um, and that's kind of cool. I like it because it's a lot of information in a little bit of space. And wanted to build my own. So this is going to be a code walkthrough of how I use the Raspberry Pi, Philips Hue, and actually a TP-Link too, because I integrate with Alexa, to make my own weather ball. So let me describe what I've got. We've got a Raspberry Pi that does all the software. We have a Philips Hue bridge, which has a fixed IP address on my network. We've got a Philips Hue bulb that's a LED bulb that can change colors. That's inside an Ikea lamp. And then in addition to that, we have a TP-Link um, AC adapter so that I can turn it on and off through Alexa. Now, Alexa does support Philips Hue natively. Yes, I know that. That's not how I implemented this for a variety of reasons, but anyways, so that's how I got the Alexa to work. So I'm not going to show you any code for the Alexa piece because all it is that a Kia lamp has a toggle on-off switch. It's always on. It plugs into an AC TP-Link plug-in, and that plug-in is what I control through Alexa. So I'm not going to show you how to do Philips Hue through Alexa, although we can do that some other time, but not in this one. Okay, so let's start with the code walkthrough. I am SSH'd into my Raspberry Pi, and I will show you what I've got on there. And basically, I've got one script that connects to OpenWeather, or the OpenWeather API. So you'll need to go to OpenWeather, and let's see where I go here. So yeah, I have to go to OpenWeather API and get a key, an app key for what you've got, and then you'll be able to ask that thing what the weather is periodically. And so let me open up weather ball, and I'm using no key. I'm using VI as an editor. You can use whatever you want. Doesn't matter. You can use Nano or Pico if you're unfamiliar with all the VI commands. That's fine with me. So we are importing from Philips Hue bridge, so you'll have to do like a pip install Philips or phue to make sure you get that in there. That way you can talk to your bridge and be able to control any lamps that are on your network. We're going to use time, of course, and openweathermap core. We'll bring that one in too. And so this is what we're going to use to talk to our OpenWeather API. And then this is what we're going to use to talk to Philips Hue. This script actually does a few more things for a few different other lamps that I have in the house, but we're going to try to ignore all of that, and maybe we'll talk about that one in a different little walkthrough. But for right now, the important parts are we've got a bridge. This is a hard-coded IP address. I've set on my router to always give the bridge that IP address. That way I know where I'm going. Yes, there's probably ways to go out and broadcast for it. But I have multiple bridges on my network, and that would get relatively confusing pretty quickly, I think. So this bridge is the one that I'm looking for. I've got it hard-coded. We've got some defines here that tell us if we're red, green, or blue, and what color is our light currently. We'll start it out with red, and then we'll come down here. So it's all in Python, And we're going to create our bridge by finding it here with our defined bridge, which just is the IP address, and this little constructor here for our bridge. Once we bring in the Philips Hue library, that's going to give us a reference to that. This is our weather ball name, Hue Color Lamp 2. That happens to be the hard-coded name of the color-changing LED that we're going to use for the weather ball. The sunlight name, that's a different project. We won't worry about it. We're just going to worry about this one right now, the weather ball name. And that way, when we're trying to connect to a specific bulb on our network, we're always going to connect to the correct one, and that's what these things are for. Let's see. And then we've got these helper functions that are going to say, set solid bright red. So here is our colors that we're going to do. We're going to define some variables that we're going to bring in, our global variables that we've defined for, what colors are we setting. We'll go through all of our lights that our bridge can find right here. The bridge is going to get our light objects. We're going to get an array of these things. We'll go through each one and double check to see if it's the weather ball name, because that's the one we want to set the color to. And we're going to set our brightness to bright, which is all the way up. And then our values are 1 and 0.5. That's if we're setting it to red. Now if we want to set it to blue, it's going to be the same thing, but this color down here is going to change. And same thing for green, just the colors are going to change. And I messed around with these colors. They're not exactly, they're pretty good. They're not exactly right, but they're pretty good. Okay, so now we come down here, and this is where we're going to get our light state. We're going to use our Open Weather API key, which is this thing right here. So when you log into Open Weather, get your account, you'll be able to get an API key that you're going to use. And there's a free one that allows you to get certain things for, I think you can get like 100 items a day or something like that for free. And then after that, you got to pay for it. So it's it's plenty for what we're doing. So here's my app ID. It's not what you want to put in there. You want to actually put your app key in there. Now I'm going to get my daily forecast, and this is the ID of my city. And I kind of figured that out just by goofing around on their website and typing some different things in. So this is for my zip code, ends up being with this ID here. So that's where that came from. And then we're going to pass it the settings, which are how we're going to log in, and of course units. We want this back in degrees, not necessarily Celsius. Okay, today and tomorrow we're just going to initialize some things. We're going to get our data out of here, and what we're trying to find is our min and max temperature for the day. And we'll come down here. This is all parsing through it, and you'll see like later on that I've got a different way of parsing this JSON object. It comes back in kind of a weird format that it didn't look like real JSON. When you start messing around with it, you can see how it comes back in. But anyways, I had to go through, and this is a little routine here that's going to pick out our temperature. Okay, so here's what we're going to find for today. This one, and tomorrow is the next one. So it gives you an array of temperatures coming in. First one is what today's high and low are, and then tomorrow is the second one that you get in there. And then there's also precipitation that we will find in that second piece. And that's going to tell us if we need to blink the light. Okay, so now we do some conversions here and figure out what today is, what tomorrow is going to be, and I'm printing this stuff out just for debug. And then I check and see if the difference is 1, then we're going to do solid blue. So my threshold is 1, and you can change it if you want to. Like, just play around with it and see if how much difference do you want in temperature. So I just went with 1. So if today the difference between today and tomorrow is bigger than 1, then we've got something that we need to look at. So if today is bigger than tomorrow, that means tomorrow is going to be colder. So we're going to set our light color to blue. Otherwise, it's going to be warmer, so we'll set it to red. And if there isn't this 1 unit difference, then we'll set our light color to solid green. All right. We'll check the precipitation. If it says it's clear, we're not going to blink it. If it says clouds, we're not going to blink. But anything else, we're going to blink it. Right. So it's going to be, it could be rain, snow, could be like snow mix, light rain, heavy rain. There's all these millions of strings, but these ones tell you that there's nothing happening, clear and clouds. And so those are the two that I look for. If it's not clear, it's not clouds, then we're going to say we are going to make the lamp blink. All right, I'm going to skip over the sunlight stuff because that has nothing to do with this one. So now we will update our light display, and we're going to come in here and we're going to say if our blink color is 1, then we have our min bright value, which I think is like half, and then our max bright is like full all the way up. So if we need to blink, then we will check and see here if we need, we will just toggle our brightness, and then we'll come down here and make sure we set our colors correctly, and update sunlight we're not going to look at. But then we come down here to our main loop, and we are sleeping for a little bit. We'll say we'll update our light state always, update the display, and then we'll go around. So it looks like, I'm trying to remember what I put in here. Wait ticks, time, this while loop is sleeping for 2 seconds, and wait ticks +1. So it looks like 60 seconds. Every minute we're updating this thing, and we're just going over and over and over and over again, around and around we go. And so that's the idea of what we've got going on. Now let me just search for one more thing. So here we're setting our global variables for our brightness, which is we're going to use for our pulsing, and then we're going to call these functions. But I just want to look up how we use it. Brightness right here. Light.brightness equals bright. That's where it was. So every time we call this thing, we're going to check and see, if we need to adjust the brightness, and that's what we're going to do. So for pulsing, we're handling that toggle of the pulsing of the brightness down at the bottom in our main loop. Down here, actually, inside of update light display. Sorry about that. This is where we're handling adjusting the brightness if we need to blink it. And update light display comes down. How often do we call that? We come in here. That's every 2 seconds. So what's going to end up happening is our light's going to be pulsing every 2 seconds if we need to. And then every minute we're going to get an update from our API to say, to just double check our temperatures and see if that works. So that's how all that goes. And then as far as the startup goes, let's see. On your Raspberry Pi, if you want this thing to boot up, so you want this to start all the time when you boot up. So the way I did this is a Raspberry Pi 3 .config lx session lxde pi, and now we have, so in this directory, and assuming you're using the default user of Pi, we will have a auto start. So it's home pi, home pi.config lx session lxde pi, and now there's an auto start script in there. And then this is what I have in mind. I've added this line. So just above the at x screensaver at the bottom, I added this line here, at lx terminal-e/home/pi start weatherball.sh. So this is going to spawn an LX terminal running this start weatherball script every time we boot up. And if we look at that start weatherball script, it's just an infinite script. I put a sleep in the front here because sometimes it takes a while for the network to get going, and so I said, well, we'll just let it sleep, make sure everything's up and going. You could do a much better job of that if you want to. For example, you could check to see if the network's active and then not launch the script until it is. But for the most part, who cares, right? It's how often is this Raspberry Pi going to be rebooted? Probably never. We'll check in a sec how long this one, actually, how long has this been running? Okay, so mine's been up for 30 days. I bet before that it was probably several months. Whenever the power goes out is essentially when we're going to reboot this thing. But anyways, so then we happen in this while loop, and we're going to run this weatherball.py. That inside of it, this weatherball script that we were looking at earlier, that has an infinite loop in it. That should never die out, but for whatever reason, should it crash, we're going to sleep for a second, and then come back up and restart it. So this almost ensures that this, as long as there's nothing wrong, like majorly wrong, like you lose your network or open weather goes away, that sort of, or the Fill2 hub disappears. This is going to catch all of our errors that we're going to have, and it's just going to keep running over and over and over and over again. And that's how I do that. So yeah, so this is how I did the weather ball. And like I said, the Alexa integration was just with a TP-Link AC adapter. You can look up how to do those somewhere else. Those are pretty straightforward to use. But this is how I made my weather ball, and I hope you make one as well.